So continuation of the lecture number 6. We start from here. In the last lecture we have already mentioned that the value of the last tree. This one is 34, this one is 36, this one is 36, this one is 34, this one is 32 and this one is 35. So you should start from the least value. Whatever may be the level of the branch, it's the second level, it's the first level, but still if you got a minimum value of any level of the branch, then you should start from there. So we start from here. 32 is the least value because according to the all branches, this one is 35, 32, 34, this one is 36, 36 and 34. So you start from here. Clear? When you start branching from the first level, you always consider that which city should be the next city after the city 2. So our coefficient should be 2, 1, 2, 4 and 2, 5. It's represent you can move from 2 to 1, you can move from 2 to 4, and it's represent you can move from 2 to 5. Okay, so the question is why we not consider 2 2, because 2 makes a self loop that should not be a full tour. So we should discard from the case 2 2. Another you should discard is 2 3. The question is why we should not consider x 2 3. It's represent that you can move from the second city to third city, but still we cannot consider this case because the branches start from here. The previous level says that you just move from the first city to third city. Since we move from the first city to third city, that means you cannot move from any other city to the third city. So sorry, so here we should not consider x2 3. So in the second level the branches are 2 1, 2 4 and 2 5. I think it's clear for you. When we consider x2 1, that means you have to delete from the first table 1 2, the first two row, and first column and third column, first column and third column. Okay, so we move to the next level. From this table you just move 1 2 and the set case third column and the first column. Move to this step 4. Here we consider x1 3 equals to 1 and x2 1 equals to 1. That means we move from the first city to third city and the second city to first city. This should be the graph. 2 2 1 1 2 3. So the remaining case arises this 3 4 5 should be the row and 2 4 5 should be the column. The consider here we should not consider 10 because we cannot consider 3 to 2, because if we move from 3 to 2 it's become a short tour 1 to 3 3 to 2 2 to 1. So you should discard this result and got only the minimum value, that is 8 5 and 6 is more than one place, so you have to consider only one case. So the total costing for this tour should be see 8 plus 5 plus 6, and that should x1 this one is x1 1 3 and second one is x 2 1. x1 3, the costing is x1 3 is 1, that means you just move from the first city to third city, the costing is 8. Here we mention the costing, and the second city to first city the costing is 10. So the total costing is 37. So in the second case, when we consider the next case x2 4, that is 1. If we consider you just move from the second city to fourth city, what happened? That should be happen that you just delete the first row and second row and third column and fourth column. The remaining table should be exactly in that case x 1 3 1 and 2, the first two row are deleted and third and fourth column are deleted, so the remaining column are 1 2 5 and the remaining row are 3 4 5. In the same concept we just delete 3 to 1 because you cannot move from 3 to 1, it's become a sub tour, so you have to delete this one. And another one is 4 to 2, that means you just move from 2 to 4, you cannot move from 4 to 2, so you have to delete this case. So the remaining minimum costing here we mention under the blue color 9 6 and 6, so the total costing is 9 plus 6 plus 6, and 8 is the costing for moving for first city to third city, and x24, that is the case for the second city to fourth city, the costing is 5, so the total costing is 34. Next we move to the third case. Third case is x13 is 1 according to the T structure. According to the T structure, this one is your T structure. 2 5, that is equals to 1. If we consider x25 equals to 1, that means you should delete the first row and second row, third column and fifth column. Clear? If we delete the third column and fifth column, what happened? We just got this particular matrix, got this matrix, we got this matrix, got exactly in this matrix 1 3 1 2 5 1. So here we delete the first row and third row and third column and fifth column. The remaining matrix is this. Why we cancel this 8 with the green color? Because since we move from 1 to 3, you cannot move from 3 to 1, so 8 should be deleted. And another deleted is 5 to 2, because you just move from 2 to 5, you cannot move from 5 to 2, so you should delete this one. Okay, 5 to 2. Clear? So the remaining costing becomes, so the costing becomes 8 plus 5 plus 6, 8 plus 5 plus 6, and 8 is for 1 3 and 6 is for 2 5, so the total costing becomes 33. So we move to the next level of the tree, this one. So here we write 37. I think it's clear for you. This one is 34 and this one is 33. So if it's your second level branching, now the minimum number, again we consider the minimum number, where all consider all the branches. This one is 34, this one is 36, this one is 36, this one is 34, this one is 33, this one is 34, this one is 37, and this one is 35. So the least value is 32. You should consider to start your branching from 33. Clear? So if you clear about that, continuation of 5 6, and that should be your 7th lecture. Next lecture we start the branching from here, and we got a particular result. How can I find this result? So stop for this class, we move to the next class.